I will be talking about impact of artificial intelligence on future of data center cooling. Um, all of us know what we are hearing nowadays, artificial intelligence in every day-to-day life. We are talking about ChatGPT, Copilots, Gemini, and so on. That is on personal use, but what it is going to get impact on data center cooling requirement and also for real-time application for business purpose. That is what we talk about, and then what challenges it poses. A part of it is already covered by Mr. Puntianis. Thanks for that. So starting with a report from renowned industry, Omdia, which talks about the growth of data center install base over a period till 2030. And we can say clearly from 2020, the year of COVID, to next decade, that is a year of 2030, the growth in terms of install base from 40 gigawatt, it is going to 180 gigawatt. Massive growth. It poses a lot of challenge with respect to sustainability, available manpower resources, and technologies which are going to be a part of data centers. Out of that, if we classify workloads which are going in data centers, we see massive rise in artificial intelligence workload going into data centers. It might be into inferences, training modules which are going into data centers, and also non-AI workloads, which are typical workloads and high performance computing, which is part for computation. Both will be growing, and out of that, artificial intelligence will be growing at a very, very rapid speed. Omdia only talked about projections, but in terms of real life of applications which we are seeing in day-to-day life, it is practically hitting all industries related to be healthcare with respect to diagnosis systems, personalizing the offering for diagnostic systems, and research. In agriculture, education, cloud, marketing, media, entertainment, government, universities, energy, oil and gas and mining and manufacturing, finance. These are something which we have just listed over here. Practically in all sectors and segments into industry, we are seeing inroads of artificial intelligence. Few of them are highlighted over here. That actually puts a lot of inference that whether with inroads of artificial intelligence, the current cooling technology which is used in data center is going to be sufficient or not. And a second question comes, what will happen to existing technologies, whether they will be sustaining or not? That's two things which actually we will talk about in detail, and at the end of the presentation, that's what will be conclusion of this slide. What will be the future in data center? Going to next chart, and which talks about projections from NVIDIA. Again, this data is taken from NVIDIA, and what this chart talks about, just concentrate on this. If in a current scenario, top 500 colo and cloud customers go 100% on CPU-based computing, they will be consuming around 5 terawatt hours of electricity per year. These are only top 500. It is not 100% of the users which are using IT compute system. And the electrical, this consumption will lead to around $750 million OPEX going into this compute. And what will be the compute by these companies will be something around 5 exaflops. These are the terminologies which most of the IT compute guys may be more familiar with. While as if entire computing from CPU based is moved to GPU based, the power required for the same compute will come down to just 1/5 of it. It will come to 1 terawatt hour for exactly same compute, and resulting this operational cost will come down to drastically from 750 to 150 million. That's a great thing which GPU based computing will help and enable. At the same time, if we talk about compute capacity from the GPUs due to processing powers, how they operate, it will be just 5x. That means 1/5 of the energy and the power requirement and 5x of the compute capacity. That's what is driving totally on in terms of technology. Why we are talking about AI and why we are talking about GPU based computing in nowadays scenario. Second thing, okay, if we move from CPU to GPU, what happens to chip densities, which Alexander talked about? We can see in this chart itself, CPU-based computing requires more time, maybe 10x of the time for the same compute. The power TDP levels are lower, while as for same compute, GPU-based is much quicker. In fraction of second it computes, but TDPs are going higher. That's where everyone is talking about the chips which are moving from 100 watts to 1.2 kilowatt, and there are projections that it may even go to 2.5 to 3 kilowatt too in upcoming future. So Ashra has come to a guideline for all these high density servers. Specifically, this guideline is more talks about air cooling. When these loads are air cooled, it talks about a very limited bandwidth. If you are familiar with A1 to A5 series category of the servers, H series of servers, the allowable tolerance is very low. While as when we talk about recommended, it is still narrowed down. What does it impact? That whatever we talk about green, sustainable, and all other things required to have a sustainable data center for all across globe will go for TOS, because this will call about chiller operating at a lower temperatures, supply temperatures at much lower temperatures, and more equipments within data centers. So will that be sustainable? That is always a question. And that's why nowadays we are talking about new technology, which most of us are familiar. It's called as liquid cooling. And also in liquid cooling, different technologies do exist. One could be chip based cooling, where cold plates are mounted on the chips, and other maybe immersed type, where in the fluid entire server is dipped. In this chart, we are just trying to understand how exactly cold plates are getting mounted into a server. It's just one example has been taken for Dell servers, which is modeled as XZ9640. 4.6 kilowatt is total power consumption, which comprises of CPUs and GPUs. And if it needs to be liquid cooled, there will be cold plates mounted on the heat generation devices like CPUs and GPUs. And this just mounting a cold plate will not help. It will require entire infrastructure of relaying pipes, which will carry the fluids along with it. The blue ones indicates the cold fluid is coming and passing through the loops. Again, this architecture we are not going to talk about in detail, because this is very specific to the server OEMs, how they plan. So there will be one inlet and one outlet coming to the servers. And just imagine 10, 20s or 40s of servers mounted in each rack will be having this connection of inlet and outlet pipe. But again, if we see this architecture, are we talking about 100% is taken care by cold plates? Answer is no. That means rest of the parts like PSUs, memories, storage, PCL cards, which might contribute to 20 to 40% of the total power consumed by the servers, may be air cooled. So both has to exist in terms of air cooling as well as liquid cooling. Of course, liquid cooling will be dominant in terms of cooling the systems. Okay, so just introducing liquid cooling and solving the problem is that what we are looking. Okay, but by introducing that liquid cooling into data center, it is also asking to change entire data center layout itself, which talks about multiple new units coming into data center. That CDU will be required in data center, of course, for the distribution. New heat exchangers will be needed for emitting the heat. It could be chillers or dry cooler. based on ambient, based on the environment within the service. And we talk about additional services like caring about if there is any leakages, what needs to be done. One more very critical aspect needs to be understand for liquid cooling application in data center, that with high density power within the servers, the runaround time is not beyond 5 seconds. So service readiness, capability of the vendor which has been selected needs to be totally evaluated. GPU-based computing also brings a lot of problems in terms of cycling load, which is loading up to 150% of their load and then coming down to zero, and then this cycle continues. This requires specific solution in terms of power routing, power layouting, and also it enhances and asks to ensure that at the grid level sufficient power is available, which is in line with the PUE reduction, CO2 emission requirement and of the company, and directly getting to power grid. Plus, we are talking about say 100 kilowatt IT load within one rack. That means all the cables, cabling, space required for cabling is going to go haywire, and that needs to be proactively selected and talked about while designing the system.